Hi everyone, welcome to the academic video for the Bridge Project. We have a lot to cover, so let's go ahead and get right into it, starting with a topic that you've probably heard about before, force. Our simple definition of force is a push or a pull onto something. And using that definition, can you think of some examples of force? Maybe pause this video and give it some thought. Some examples that we thought of were the force that it takes to open a door, gravitational force, force from friction, and even magnetic force. Obviously, bridges have super heavy cars and trains and people that go across them. They have to deal with the force of those objects in the downward direction in the form of their weight. So let's take force just one step further into the topic of stress. And no, I'm not talking about the type of stress that makes you want to pull your hair out, but the type of stress that helps engineers ensure that their projects are safe and strong. My little brother is being nice enough to help out with this demonstration. Watch what happens when I step on him with my tippy toes, which is supposed to resemble a small surface area and a relatively high stress.
Ow, 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 ow.
But now let's introduce these textbooks, which are much bigger than my tippy toes and should theoretically spread out my weight a lot better than having it concentrated on my toes.
Don't feel it at all.
But let's try to relate this all back to bridges. What we want you to do is take one of the balsa sticks from your kit, pretend it's a log, and we actually want you to pause this video and break it. See, on the single stick, all the stress is gathered in one place, and it doesn't take much for it to break at all. But that is where bridge and truss design come into play. I promise these are going to be much, much stronger. Trusses are a design of lots of individual pieces on a bridge that work together to share and distribute the weight and load from the top of the bridge, so not just one individual is handling all that load. Believe it or not, there's one shape that's famous for building bridges and being the strongest shape in the world. It's a triangle, and here's a big reason why. You see, in quadrilaterals, look how many degrees of freedom there are, and look how easily they can shift. But check this out, as soon as the shape is split into two triangles, look how rigid it is now, and look how the movement is restricted. So now that you have all that new knowledge, we hope you're excited. See you in the next video, where we're going to teach you how to apply the stuff we just learned and build a bridge for yourself.